You ready for the spicy one? This one's complicated. You not very many people can figure out how to do this type of question without any direction to begin with. Okay, it's all about components, but we're going to come upon a problem very early on that is going to take some math problem solving skills to solve. So here we go. A stoplight is hanging from two wires as shown below. The mass of the sign is 30 kilograms. What is the tension in each wire? So we have, to be clear, this is 45 degrees. 45 degrees. And this one is 37 degrees. Not a good photocopy, but I didn't want to make a new one myself. So, same situation as before, equilibrium is happening. So we've got the force of gravity pulling down, and that force of gravity has to be balanced out by the two Y tensions in the cables. Okay? The temptation with this question is to draw a single Y tension here that's shared between the two, and here's the X tension to the 45, and here is the X tension to the 37 degree angle, and you assume that T1Y, so let's call this T1 and T2, you assume that T1Y and T2Y are equal to each other, and that is not true. This is a tricky one because the distance is the same. If we were to draw these two triangles on their own, they would look something like this. Here's our T1 triangle and our total T1. Here's our T2 triangle, something like that, and our total T2. And it looks like T2Y and T1Y should be the same thing because they're the same distance, right? If you were to draw a line from here to here, no matter which triangle you're talking about, the T1 or the T2 triangle, you're going to get the same distance. But that is not the same as force. Just because two components are the same length does not mean they have the same force. That's an odd thing to get your brain around, but it's important. And so it's easier to look at it this way, as two separate triangles, and not try to match sizes. Okay, so this is 45 degrees, and this is 37 degrees. And we don't know anything else about those forces, okay, about the tension forces. The only other thing that we're given is the mass of this stoplight. It's 30 kilograms. So the first thing that we can do here is figure out what the force of gravity is, right? So the force of gravity is mg, which is 30 kilograms times 9.8 meters per second squared, which is 294 newtons. Okay, and so we know that our vertical forces, our vertical tensions, T1Y and T2Y, they need to balance out that 294 newtons of gravity. So what we can say is that let's put it over here. We can say that T1Y plus T2Y is equal to the force of gravity. We know that our Y tensions must balance out our force of gravity. Now usually, up till now at least, we've been able to figure out what those Y tensions were, and so then we could figure out the force of gravity as well. But let's look at these triangles up here. If we look at the T1Y triangle over here, we are given the angle. We are not given T1 total. We are not given T1x, and we are not given T1y. So in order to solve for any piece of a triangle, you need to have two parts of it. You need to have an angle and a side, or two sides. Okay, but we have nothing. Well, I mean, we have one angle, but that's it. And so that's kind of where we get stuck. we cannot solve for either of these two variables in this t1y plus t2y equation, right? We have two variables. We can't solve for either of them. We have to be able to fill one of them in before we can solve for the other one. And so we have to do this thing called a system of equations. Okay, that's the math skill that I was talking about earlier. So let's look at how this goes. We're going to write equations for all of the components. This is T2. T2x. And this guy is T1x. Okay, so we have equations for all of this stuff. So T1y and T2y, we can have an equation for that. So T1y is equal to T1 times the sine of 45 degrees, right? Because if we look at our triangle over here, T1y is the opposite side, and so we need to use sine for that one. So it's sine 45 degrees. And T1x, the other component, is T1 times the cosine of 45 degrees, because it's the adjacent side. And we can look at the other triangle the same way. T2y is equal to T2 times the sine of 37 degrees. And T2x is equal to T2 times the cosine of 37 degrees. Okay, so notice this. We had 4 variables that we were going to work with. T1y, T1x, T2y, and T2x. But now we have equations for each of those things. So rather than writing T1y, I'm going to write T1 times the sine of 45 degrees. And rather than writing T1x, I'm going to write T1 times the cosine of 45 degrees. So now instead of having 2 different variables to describe those 2 different things, I have 1 variable and some trig. Okay, so that's going to help us a little bit here, because T1y now is T1 times the sine of 45 degrees, and T2y is T2 times the sine of 37 degrees. And those 2 things together, they equal 294. We can fill in the force of gravity. But I haven't really improved my situation here, have I? I had 2 variables, 2 unknowns in that equation, and I still have 2 unknowns in that equation. So let's look at the other side of things. Let's look at our x components. We have to ask ourselves, what do we know about our x components? The stop sign is not moving, right? It's in equilibrium both in the y direction and in the x direction. And so that means the leftward pull has to be equal to the rightward pull. And so then we can say that T1x should equal T2x. Okay, both of those things should be equal to each other. And so we are going to substitute in there our equations for those things. So we're going to say that T1 times the cosine of 45 degrees is equal to T2 times the cosine of 37 degrees. Okay. Now again, there are 2 unknowns. I cannot solve for either of them. So here's where that system of equations thing I talked about comes in. So if you remember anything about systems of equations, you know that there are 2 ways to solve a system of equations. A system of equations is just multiple equations that use the same variables. So now we have 2 equations that both use T1 and T2 as their variables. So our choices to solve a system like that would be substitution or elimination. And some of you are going, oh, those. Yes, those. So we're not going to use elimination because that would be ridiculously ugly using trig. instead, we're going to use substitution. And it's fairly straightforward at this point. So substitution means that I need to write one of the variables in terms of the other one. And so I'm going to look on my x side over here, though you are totally welcome to do it using the y variables instead. It works both ways. It's just that this seems a little bit more straightforward to me. So t1 is equal to t2 times the cosine of 37 degrees divided by the cosine of 45 degrees. Okay, so I've just divided both sides by cosine 45 degrees. So now I have a new expression for t1. And so now instead of using t1 over here in this equation, I'm going to substitute in my new expression for t1, which now puts it in terms of t2. So instead of writing t1 here, I'm going to write t2 times the cosine of 37 degrees divided by the cosine of 45 degrees. Now I've substituted in my new expression for t1. So now I will continue writing the remaining pieces of that equation that are still there. So I still need this sine 45. It's easy to forget that one because you've concentrated on writing all the stuff you needed to in the t1 spot, and you forget that there was a sine 45 attached to that t1. So don't forget that. Plus t2 times the sine of 37 equals 294. Now I'm going to forego the newtons on the end of that for now because we're going to have enough numbers to deal with without also putting in units there. I'll just remember them for later. Okay, this is still really ugly, right? But here's a t2, here's a t2, and there are no other variables in this equation. So I have an equation with one type of variable in it. It's just in multiple places. And that means I can solve for that variable. I just need to gather like terms and combine them, right? That's really ugly looking as it is, but all of this trig stuff, like they're just decimals. If you convert them all to decimals, you're just going to end up with some decimals. Now, if you want to get an exact answer for this thing, you don't necessarily want to convert everything to decimals, but I think for the sake of understanding how this thing works, let's just skip that concern for exactness, that concern for not using rounded numbers, and just round some things for now. So for this t2 times cosine 37, divided by cosine 45 times sine 45, all of that stuff together is t2 times 0.7986. Okay, that's exact enough for me. That's 4 decimal places. Okay, at the very beginning, we were only working with 2 sig figs. If you look at the angles, 45 degrees and 37 degrees. So in the end, we're not going to need that much precision anyway. So this is fine, 0.7986 plus t2 times the sine of 37, and the sine of 37 is 0.6018. And together those things equal 294. Okay, now think of it like this. What would you do if you had 2x plus 3x? How would you combine those things? You'd add the coefficients, right? You'd get 5x from those things. Well, the way that I've written this t2 equation over here, it would be the same thing as writing x2 plus x3. And we don't generally write algebraic expressions like that. We put the number in the front as the coefficient, but it actually works exactly the same way. X times 2 plus x times 3 is the same thing as x times 5. Okay, and so we can do the same thing with this t2 thing. We just need to add the coefficients. So when we add the coefficients, we get, and I'm going to put the coefficients in the front now, we get 1.4004 I'm using 4 decimal places, even though there's a 1 in the front, times T2 equals 294. And so we get T2 is equal to 209.94 newtons. Now, we actually only want 2 sig figs from that thing, so our final answer is going to be 210 newtons, but let's just leave it like that for now because we want to use that number in our calculation for T1. So notice way back over here, we have a formula for T1 that uses T2. So we have now calculated T2, which means we can fill that in our formula for T1. So T1 is equal to 209.94 times the cosine of 37 divided by the cosine of 45. So T1 is equal to 237.11 newtons. Now, we should round these correctly, though I'm not really too fussy about that. Our T1 with sig figs should be 240 newtons, and our T2 with sig figs should be 210 newtons. Okay, I'm not going to put a direction on there because at the very beginning of the question, it gave us the direction of those things, right? It's there and over here. The point of this question was really to calculate the magnitudes of the tension in each wire. Now, I understand how it is difficult for a lot of people to look at this question and go, how would I have thought to get here on my own? Right? Because often you're reading a question and you have to decide on the method that you're going to use to finish it. And you can't just memorize all of the methods that there are, right? I want to encourage you that everyone has that same thought. How would I get here? And that there is really only one type of question that leads you here, at least in this unit. We'll see this exact method again a little bit later in the course, but in this unit, this is the only type of question that you'll need to use this method for. And so what you need to be able to do is recognize what type of question it is that you're looking at. So the giveaway for this one is that when you draw your triangles for splitting up your tension vectors, you only have one piece of information, and it's the angle. That's all you have in there. Okay, that is how you know that you are not going to be able to do anything except for a system of equations. In any other circumstance where you have more than one piece of information about those tension triangles given to you, then you are going to be able to solve it using a different method. You're going to be able to fill in more information in the triangle. So what you have to look for is, how much information can I actually fill in about the components of these tensions? And if your answer is I can fill in just the angle, then that's a systems of equations question, a substitution question like this. Okay, so look for that.